All right, once again, good morning. If you're just joining us, we were just quickly chatting and we were looking at the calendar. It's November 8th, a week from today. On November 15th, your final prototype is due. In fact, all of Project 2 is due. So we'll talk about the remainder of the drawing deliverables that I want from you for Monday as well. So again, if you look at the modules, Project 2 introduction. Yeah, so all the way at the very beginning, we anticipated mid-November, trying to wrap Project 2 up. And that way, we clear the last couple of weeks, last few weeks for you to do your studio work without having a lot of extra 367 work to do. All right, we will have a Project 3. Don't get me wrong, that last part of November, but it'll be light. And it'll be stuff that if you just come to class and follow along as we do it in class, you won't have any outside work. So inevitably, some folks don't do it in class or they put it off. I don't know why. And then they end up having to do it over finals week or something. Beats the hell out of me why someone would do that. But that's my promise to you. If you just come every day on time, over that next, after November 15th, for Project 3, you'll get it done in class. So no outside work. You just do it in these 1.5 hours that we meet twice a week. Bam, be done. All right, which is always fun. All right, so anyway, that's what the calendar looks like. We're here. Now I mentioned performance modeling. I'm just going to show you what I meant by that. And I'm going to show you some of the things that we can do in Grasshopper, but you're not going to be required to do it because frankly, we're just out of time. I don't know what happened to the calendar. I blame myself. But I'll show you a little bit about what that means and where you could take this if you were really interested in that, particularly for your studio projects. So let's see. Again, prototype 2.0, your final prototype, laser cut prototype due a week from today on November 15th. As well, and I'll post this, the other part of the assignment, the other part of Project 2 deliverable, final deliverable, the drawings, right? So last time we talked about ta-da, this exploded axon, right? Sort of showing how these things can actually, which piece goes where. I haven't added, I need to clean up these tags. They look kind of goofy. And I hadn't added any dashed lines to sort of show the projection, direction, if you will. We also talked about laying out the sort of catalog of the components here. These would need to be labeled as well. Instead of, I'll go over the demonstration today will be over how to generate a sort of phylogram or sort of this idea of showing the sort of parametric capacity of your shading system, right? You have this component, and if you start to adjust the slide bars, you can actually make lots of different variations of it. So this does actually sort of imply that you could begin to fine tune each of these components, each of these cells, based off of some performance criteria. I'll talk about that again, just to sort of show what we would have done if we'd had about another week or two. Yet I'm not sure why we ran out of time, but it happens, I suppose, right? So this is what everybody has, right? A surface. We have, I don't know, some ribs somewhere, right? Probably under here. These strips and U strips, right? We have some components that were baked in from Grasshopper. Now, what you'll notice is that all of these had the same parameters plugged in, all the same variables, right? So there was a height, and each one of those had the same height. And then there was a U and a V coordinate, in my case, for this sort of peak, this apex right here, where these two sides of a pyramid meet. And those are actually the same across the entire shell, right? Now, it's not lost on me that, because we're laser cutting this, and so and all of this is being managed in a parametric model, is that some of these might actually be facing more of the sun. Maybe they're south facing, and some of these might be north facing, right? Some of these cells, and so what we might want to do if we're actually trying to shade is to begin to understand which of these components, which of these cells actually get a lot more direct light, and then actually close up, actually make these cells a lot more opaque, right? In other words, we could begin to alter the properties, the variables, or the parameters of each of these shading components in order to sort of close some of these apertures up where we need to, and then open them up on the north side where we actually have shade already. Okay, So again, I'm just going through this just to show you, to whet your appetite. It's not something that we have time to do this time around, unfortunately, which is odd, but I'll just take you here. I'll open up Grasshopper, right? Measuring performance. So in this case, I have the same profile, the same graph that you guys were using before, in that I plug in a surface. I tell it how many times to divide in the U and the V direction. So 15 cells each, let's say. What's going on here? Come on. All right. You know, I give it a height. I'm basically making my shading components and things like that. Just going to turn these off for a moment. Turn those previews off. Preview off, preview off. Preview this off. All right, just get these things out of the way really quickly. Turn that off. And so one of the first things we're going to do, or what we would do, right, is ask ourselves, well, what are the criteria here? If I, let's see, do this, I'm just going to go ahead and clean some of these things up. You can see I'm still making my shading components in this one and flattening them all out. I'm just going to quickly turn those off really quickly, just so they're out of the way for the time being, and just show you what I'm doing here. All right. Okay. And so what I've done is I've drawn a few rays, let's say for mid-morning on one of the equinoxes, like let's say September 21st or March 21st. Right? So these are a couple of the sun rays that we would encounter, let's say from, let me think about this for a moment. Let's say if the negative x-axis was north, so north was sort of facing to the left in my top view, then this would be sort of, you know, an hour after sunrise all the way to about solar noon, right? So late morning. All right. So what I've done is I provided rays, and then what this simulation does, this graph, is it takes my surface and it takes each of these rays. It divides this surface up into a set of points, right? Converts into a mesh, and each of those mesh triangles has a bunch of vertices. And then it populates each of these vertices with these rays, right? And then it measures which of these rays actually hit directly, the angle of their direction. So if they're, you know, perpendicular to it, and there's, you know, that's going to hurt more than, you know, if they're at a more oblique angle. And then in places over here where you see blue, right? These are areas where each of those points are populated with the rays, but they're actually, the rays are occluded by the rest of the geometry, right? So the surface actually self-shades itself along the northwest side here, since we're measuring for morning sun angles for a particular date, right? Okay. So it takes all of that information and calculates the amount of solar radiation hitting each of these points. It takes each of these points and then basically averages them out across each of these cells, takes those averages, it looks at the maximum, the minimum, and it then assigns colors, red being the max, blue being the minimum, and then maps those colors back onto the mesh, right? So not only can we get a bunch of numerical data for these sort of energy values, right? The amount of light, solar radiation hitting each of these points, but we also see the visual representation of that mapped out with this false color gradient, right? So now we start to understand that the red areas are the ones, the sunniest and the hottest. The blue is the coolest and shadiest. And we get some yellows and oranges in between, right? Just as we would see here. All right. Okay. So that's how one way we could begin to measure performance, let's say for our shading components, is what we need to understand, I guess, is where are all the hot spots, where are the trouble areas along our shell, so that we can begin to use those values. Now we know that, let's say, the red areas, we need to have some much more robust shading components, right? That really sort of hang and shingle and overlap and don't allow a lot of light through. Over here, right, where it's blue, in fact, the darkest blue, we can have the least robust shading components. They can be really shallow. They can be quite open, right? We can allow views in and out because we don't necessarily have to block a bunch of light, right? What this is telling us is that this is already in shade, okay? All right. So anyway, again, this is just something I'm showing you guys. This is normally what we would do. We would start to measure the performance. I'd give you a set of rays, sun rays to measure. Okay. And then in the next step, not just measuring the performance, but then using that performance data and using it to complete the feedback loop in the parametric model. We would actually take those energy values.
Oh, do I have those? I keep meeting them all the time. Honestly.
Someone's talking.
Like,
you wouldn't mind muting yourself.
Feels. I used to have a come over before.
Mute. There we go. Sorry, Nathan, you're muted now. All right. So, anywho, it's weird that we have to do that. So, back to this. Right. What was I talking about? Oh, yes. Okay. So, again, taking these energy values and not just plotting them out as color values so we can see what they are, but then using those values to begin to inform the parameters for generating the shading geometry of itself, right? So in this case, we're not just picking a height and a UV value just willy-nilly, but we're letting the data actually make those values for us, right? So that what we end up with is a sort of gradient where we get really closed cells over here, right? And really open cells over here, and they sort of gradient out across and in between, right? So let me just show you the difference between those. I'll just close this if I baked the different components in. If Grasshopper closes here, I'll show you, right? So here's my surface. Here's the baked components if I was just using a general height, one height for everything, and one UV parameter for everything, right? You can see it's quite open. And if I adjusted those things the way we had it before, right, then all of them would get more closed or more open or more deep, right, or deeper or shallower based off of those parameters. If I use those solar data, and so I plug in a different solar value, energy value, right, for each cell, and then each cell gets a slightly different height and slightly different UV value, right, then we get a system that really closes up over here where it was most red and really opens over here where it was most blue. And then it sort of gradients out in between, right? So we can see that UV changes cell to cell. And we can see that the height changes cell to cell. Sometimes it gets spikier, sometimes it gets less spiky, right? As it moves across. Based off of, so now we're measuring performance, right? Measuring our criteria. In this case, shading, the amount of solar values, the amount of solar radiation hitting each cell. And then we're using that information to directly inform the geometry that we made, right? Okay. So that would have been a fun thing, in which case we would have shown these sort of, these false color maps showing the data across the surface, and then showing how the components start to close up and then open as they move across in both directions, right? Based off of that data. We just don't have the time for that. And but I'll post these graphs for you if you are curious or interested in this stuff, right? The most I can do is sort of whet your appetite here. And for those of you who really do want to leverage computational tools to do some serious design work, you can, right? Then I'll make you much more valuable. Perhaps maybe, you want to go to LA or New York or Houston and work for one of those firms that does a lot of cutting edge work, then this would be a nice piece to put in your portfolio, right? So anyway, in the meantime, I did want to show you guys something else. So let's go ahead and close this out. Do I want to save changes? Nah, no, not even gonna bother. All right. But I did just want to talk about what we would do. If we hadn't run out of time, it would have been nice, but sadly, alas, just was not meant to be. All right, so here we go, right? Again, we went over this exploded axon on the 3rd, the last time we met, as well as laying these components out. And I'll go back through, maybe if I have some time here at the end in this demonstration, I'll start to arrange these labels and start to clean this up and maybe add some captions and make these more presentable as far as a set of drawings go. But what we're going to talk about today with this workflow is to sort of show this variability, right? we have a genotype, right? We have, let's say, a dog, right? We've made some sort of organism here. In this case, it's a, we have some ingredients, right? We have some of that DNA, the genes, right? The sort of the parameters. And then we have the output, right? So let's say this is a dog. Now, what's interesting is if you look at the dog's DNA, the genotype, you change some of that DNA, the dog gets taller, or the dog gets heavier, or the dog gets longer legs, or the dog gets a longer snout, right? There's just, a certain amount of genetic difference between, let's say, a Schnauzer and a Maltese, right? Yeah, or a Great Dane and a Dalmatian. Right? What we can do now is we can actually look at our own genotype, and we can change and start to bake out a bunch of phenotypes when we alter our own parameters, our own DNA, right? For this, right? So in this case, I was changing across from left to right. I was changing those UV parameters, right? So over here, the UV for this peak, right, was all the way over here, and we have a really sort of closed off cell, right? The shading component sort of covers the entire thing. It's overhanging it and closing it off. Over here, I had it more towards the center of the cell, right? And over here, I had it almost to the other corner of the cell to make a really open cell here. So each shading component isn't shading a whole lot over here. It's shading about half of the area over here, shading most of the area over here, right? So from left to right, I'm changing those UV parameters. And then from top to bottom, I'm changing the height or the depth parameter. So here you can see this is only a half a unit or half an inch of pull up, right? Here there's an inch of pull up. Here there's an inch and a half of pull up each time, right? And so each of those, as I move from left to right and top to bottom, right, are going to give me, each of these has a sort of different set of parameters, right? The same graph, it's the same model, it's the same design, it's the same shading components, but we can begin to create this sort of serial differentiation, right? We can give it that sort of repetition, but repetition, each one slightly varies, right? Sort of serial variation, which is kind of an interesting way of looking at it here. And so if I wanted to, again, be consistent here, I would take one of these text labels that I've already made, make sure it's the same typeface and the same type size here. And I would maybe height would equal 0.5, right? I would maybe talk about what these variables are. Let me just paste in place here, make it easier to sort of slide these over. So I'm just going to quickly copy, paste in place, make another set of these downwards, and then I'll go ahead and alter them. Copy, paste in place. Oh, come on, sometime today, Illustrator. There we are. Okay. So here U and V stays the same. Height changes to 1.0. This one, the height changes to 1.5, not 1.6. Come on now. This one goes to 1.5. This one goes to 1.5. This one's 1.0. This one's 1.0, right? This one's 0.5. This one, the U is 0.5 and V 0.5, about halfway over, right? Go ahead and change these. Okay, and what I'm doing is I'm just showing these are more like 0.9 and 0.9, but let's go ahead and put that in. Okay, and I'll demonstrate how you can do this in a moment, but again, just sort of going through, making sure everything's sort of nice and cleaned up here. 0.9, 0.9. That should be 0.5, right? 0.5. All right. Okay. And so, you know, I used the word phylogram a little while ago, right? And that's a word that biologists use when they're talking about, let's say, insects, and they have this sort of, you know, graphic sort of flow chart showing how different species of butterflies are related to each other, right? Based off of this sort of DNA, right? The sort of genes. And if you think about these parameters as a sort of genes, right, we can begin to create different species of our shading component here, and then begin to bake them out on their own, right? To sort of show how nice and resilient and variable our design is, right? Each of you have a different sort of type of shading component than this, but this is my example, right? Just sort of altering those parameters. So let me just show you what I did, right? And here's how I recommend proceeding. Go ahead and save this, because obviously I started back here in Rhino. I just made a new Rhino file and I made a planar surface, right? I'll just quickly delete this and show you exactly what I did. Just go through it step by step. I'm in the command here, the toolbars. I'm just going to go to the surface creation tools, right? Here's all the different ways I can create surfaces. I can loft them, I can fill in planar curves, I can sweep, I can revolve, I can drape, I can twist, I can extrude, etc. Right? Rectangular plane, corner to corner. That's what I'm going to pick right there. It's going to ask me for the first corner of a plane. I'm just going to type in the command line 0, 0, 0. I'm just going to put it at the 0, 0, 0 point, where x equals 0, y equals 0, and z equals 0 in the Cartesian coordinate space here. Other corner length, I'm just going to type in 10, 10, 0. Right? So I'll just make this a 10 by 10 plane square surface. Let's see here. Not sure why this is taking so long. There we go. All right, finally. Okay, so there's my surface, right? And what I'm going to do is I'm going to open up my shading components. You all have your own shading components graph, right? Now, remember, what you need to create shading components, the one ingredient you need is a surface to break up into a set of into a checkerboard, right? Each of those checkers, each of those cells in that grid, then that resulting grid as we divide the surface up, gets populated with your shading components, right? So I can go here and I can say right click, set one surface. I can set any surface I want, right? Including this new one that I just drew and modeled, right? And then I can go back to the U counts and I can make this a lot, you know, I think probably a lot of you had it 15, 10, 20, something like that, right? I'm just going to draw this down to something like 4 by 4, right? That's why I made a square, so I could have 4 in both directions. Okay. There, 4 divisions, right? You can see, right? I can then go back through and remember what all those parameters were that I could begin to adjust over here. There's one. Yeah, look at that. And let's see. Over here is a height or a length. I'm just going to move these over here. It's a little easier to sort of see them all at once, right? And so again, you guys have all done this, but now you can begin to play around with these, right? So if I wanted to sort of close these up, right, I could do something that looks like this, right? And the higher I make this, right, the more daylight I have between, let's say, the bottom of my shading component and the top of my grid shell, right? So I can make the apertures, right? This is the daylight here, more or less, right? In other words, to let certain light in or to create a certain angle, right? It's the same thing over here. I can begin to cover more or less, right, of each of these cells by changing this, right? So I can make this almost nothing, right, by simply altering 2 quick variables, right? And so what I did, again, just to sort of show you what I did with my grid, is I took some of the extremes. I took the minimum, and let's say a minimum, I picked like 0.5, right? Right. And then I changed this and I changed this, right? Then I went back to the minimum. I changed this to some sort of middle, then baked, and then turned it to the middle, and then turned it to the max, baked, you know, each of these things out, right? And so what I ended up with was a set of baked shading components. Here's layer 1, turn those off. Here's layer 2, just slightly higher, layer 3, just slightly taller, right? Oh, I think actually I was altering the UV each time, right? So more closed, mid closed, and the least closed, right? Then I changed the height, fully closed, mid closed, least closed, right? So I'm just baking these in each one, right? So let me just show you what that looks like here. I'll make some extra layers here, 10, 11, and 12. All right, just show you what I did. There's a grasshopper. So I might go all the way over here. I'll pick, let's say 0.5 for me. That seems to work. All right. Okay. And so I'm thinking about a 3x3 grid of sort of options showing, how I'm adjusting the parameters to generate some variability here. All right, so there we go. Here's these. I'm just going to bake these in on layer, in this case, layer 10, right? All right. All right, now I'm going to move these over here just a little bit. I can be very precise over here if I wanted to, right? I'll leave the height. I'm just going to adjust one of these at once, right? I'll go ahead and bake these in on layer 11. There we are. Now I'll move this over here. I'll bake these in at layer 12, right? So now you see I have three different versions of these, 10, 11, 12, right? I could then do, adjust the height here, right? Let's say double the height, and then go back and do the exact same thing. Bake this out on, let's say, layer 13. Move this over to the middle. Bake this out on like a layer 14. Move this over to the edge. Bake that on a layer 15, right? But the key thing is that each time, right, I'm systematic about this, and I remember I jotted down the parameters I used so I can keep track of those. So you can start to see that, all I need to do to, let's say, make something relatively close to relatively open is begin to adjust that UV, right? And when I wanted to, let's say, make something so I can see in or out of it easier or less easy, right? I can begin to adjust, let's say, the H or the heights or the depth or however you want to call it, right? The sort of height or how deep the shading component is, right? And so you can begin to see how you can alter these things to create lots of variation. Okay, that's the last part of this. And if you wanted to basically do something similar to this with your own shading component, that's the idea here. What I will do, I promise I will post this once we're done with this demonstration. Once we're done with class today, I'll post this on Canvas along with today's demonstration and the corresponding assignment for, again, that's due on the 15th. Okay, so that way you have everything all in the same place. So once I have all of that stuff, which I've already done, it's like a cooking show, right? I already have layers 1 through 9 here. I can just bake all of these out at the same time. All right, so if I think about this just for a moment, right, what I'd like for you to do is to, by default, this is probably set to something like perspective, right? Is to go to set view, right click on that viewport label, set view, isometric, and pick a good isometric view, right? Maybe I'll pick this one, why not? Who knows, who cares, right? Okay. And I have all of them turned on at once. I'm also going to zoom extend so I make sure that all of these fit in the screen, but they sort of fill the viewport, but they're sort of none of them like sort of move off the viewport, which is pretty important. All right, so I'm just going to turn all of these off except for, let's say, this one, right? So this was the first one I did. I have that original surface underneath still, right? I'm just going to do a make 2D, right? Turn on that make 2D layer, make 2D. Select the objects to draw. I'm just going to very carefully drag from right to left and select everything here. Make sure I don't accidentally move my viewport around, or move my view. Select all that stuff, hit enter. In this case, I'll pick hidden tangents lines, hidden lines, scene silhouette, viewport rectangle. I'll just turn all that on and I'll hit OK. All right. Now you can see once it's done, it's giving me that flattened axon drawing of this system on the XY plane. I can see it as an axon drawn on the XY plane in top view. I can move that out of the way, right? All right. Now I'm going to go back to parallel. I want to make sure I do not move this viewport around, right? Keep the same size, keep the same shape. I don't accidentally rotate the view or anything like that, right? And I'm going to turn on layer 2, turn off layer 1. It's time to do another make 2D. All right. Again, I'll drag from right to left and drag a window across all of this and hit enter, hit OK. Over here on top view, it's going to show me the results. I know this is going to be put into a grid, so maybe I'll snap that viewport rectangle. Make a nice little grid like that. Oh yeah, that's beautiful. All right, just move this over a little more. All right. Okay, back to parallel. Turn off layer 2, turn on layer 3, make 2D. All right. This will take, 20 minutes maybe. Yeah. Start to learn some of that more muscle memory. I'll move this, snap it over here, right? Okay. Turn off layer 3, turn on layer 4. Now we have a new sort of row in our grid here, right? So here's where we altered the height. So it has the same UV as this one over here, but it has a different height. So I'm going to hit return, make sure everything's still the same. It says view top. No, I'm going to say parallel. Yikes. Hit OK. I must have accidentally hit over here. I'll move this. I'm going to snap this right over there, right? Layer 5, I'll turn that on. This one will go right here. It'll be the center of my grid of options here. Make 2D. Let's see. Drag from right to left, hit enter. Right, I'm just going to do this over and over again until I do all 9 variations, right? And keeping them all organized here, it's going to look so nice. In fact, it looks just like this because I did this, right before class. Okay, so, and what's great about this is that it's already arranged in a grid, right? I can just right click and I can, select it all and hit file, export selected. I can export this as an Illustrator file, right? So here I say, I want to save as type AI, right? For Illustrator, save sometime today. Not sure what's going on here. Okay. Oh, it exported. Anyway, and then, essentially you get this out, right? Now, what I've already done is I've gone through and I've changed all the colors for the layers or for the lines, and selecting each layer at a time. So hidden lines. I've changed the line color, right? So there's the stroke. Turn those to black. And go here, I can change the line weights. You can see I've actually kept the hidden lines on. I've turned them to a line weight of 0.25. And I've given them a 2.1 point dash gap. So 2, 1, 2, 1. I could do that 1, 1, right? Make them a little more dense, a little less dense, however you want each time. Visible curves, let's see, what I gave that a 0.75 line weight, maybe I'll do 0.5. Right, scene silhouette. To me, I'm having a hard time understanding which part's got the scene silhouette. This looks like this should be really easy. Okay, yeah, it was. Okay, so I'll go ahead and leave that at 1. All right. And then once I have all that stuff cleaned up, I can copy and I can paste that in here with the 11 by 17s I was making with my exploded axon, right? So it might ask me, hey, you have this viewport rectangle, you had that turned off, do you want that on, etc. Right? At the same time, I could also, again, make another layer. I call this rendered sort of backdrop, right? Sort of background. What I need to do, I need to go back into Rhino. And I need to, let's say, turn on layer 1, turn off everything else. I'll go to my render settings. I'll make sure that transparent background is on, that ground plane is turned off. I'll set this to rendered mode. And then I can go view, capture to file. I can capture that same axon rendered out, just some soft shadows. Just to give I'll put that as an underlay beneath my line work in Illustrator, just to give this some tone and some depth and some definition here. I'll hit OK. I'll just make sure this is saved as a PNG. I save these each one, A1, A2, A3, B1, B2, B3, C1, C2, C3. So that way I could figure out where these things went, right? So here I could say, here's a viewport. Its width is, viewport window 3.4665 or something like that. Go ahead and make a copy of that dimension. Okay, file, place. I'll place A1, since that's the top left corner. I'll transform that, giving it the same width as the viewport rectangle that should correspond with, and then move that into place. Snap it up. Try to anyway. I need to move that onto the right layer. There we are. And if I wanted to be really precise, I could give it the exact XY coordinate up here as the viewport rectangle, right? So, okay. All right, we can lock these. Place the next one. Place. There's A2. All of these are the exact same, so width, Control V. Paste that same coordinate in. Boom, right? File, place. A3. Transform. I'll paste that width, Control V, Command V, whichever, depending on which operating system you're using. Make sure that's moved into the right place there. Place, B1. Okay. All right, and on and on and on, so on and so forth, until you have everything in place, right? Now, I'm not going to pretend that this is perfect at all. I really hate these circles, so I'm going to get rid of them. Yikes, gross. Eesh. All right, so that's one less thing I have to worry about as well. So, it's like a win-win. A win-win-win. All right, there we are. Just try to select all these circles and get rid of them. Again, that might mean I need to adjust some of these leaders. I'll use this filled in direct selection tool and just pick the anchor for this line and just move that end of the line. Get that endpoint, move these into place, really line them up with the corresponding label. There we are. Same thing over here. Move, move. I'm not really fond of where some of these labels are. I think that could actually be done a lot better. So what I'm going to do is I'll move this over here, line those up, move this one over here, align this one up with this. Yeah, there we go. Move this down, move this up. All right, I'm going to move this over here, move that one over here. Use the other selection tool, move these over to correspond. All right, just make this thing look a little better. Maybe it does, maybe it doesn't. Maybe I need to keep fine tuning. It takes relatively little time. Just a little bit of TLC here goes a long way in sort of making this thing look good, right? Okay. Right, I'm keeping all the fonts and things lined up. I'd probably make sure all these labels line up vertically. Here's another thing I need to, oops, get that other cursor, the default cursor. Label these ribs over here as well. There we are. Oops. Just try to move these over so they're a little better laid out. And funny enough, this is the U1. No, yeah, and this is U15, right? Let me double check. I'll zoom in on those labels. Yeah, U15. So this would be V0 and V15. So trying to be, you know, consistent here with how these things are labeled and where you have margins. I need to fine tune this quite a bit. Maybe I put U's over here, U15s. Maybe I move, oops, me unlock things here. I had all my other layers locked up here, so I didn't actually move something. You know, maybe I move these this way, put the U's in front of the V's. You know, when I was moving these around, I kept the sort of baseline sort of line over here for left justifying the ribs. I probably should have done that with the U's, so I might actually have to go back and sort of tweak those a little bit here, right? Get those all to sort of line up and make them look perfect, right? If I didn't do that before, if I screwed it up before, which is probably how I would put it this time around. There's user error on my part, right? You know, I could begin to sort of, you know, add, you know, small captions here if I wanted to. Oops. Maybe okay, that's why I had certain things locked. Yikes. All right, so maybe I move these down a bit, give it a little more of a margin. Maybe I move these up a bit. And maybe I try to keep a consistent margin here, top margin, get it close in the bottom there, right? So again, just sort of lining these things up, putting 3 artboards together. In Illustrator, I don't know, most of you probably know this, but the quickest way I've always used, there's more than one way to do this. If you go to the document setup up here, right, instead of edit artboards, you can select any of these artboards, you can draw more artboards. When you have one selected, you can see its width. You can change this and make it exactly 11 inches by 17, right? And that's exactly what I want, 11 by 17s, right? Well, my guess is document setup, go back to the edit artboards. I can always delete that if I only need 3. My guess is you're going to need somewhere between 2 and 4 11 by 17s. But what I want you to do is to have exploded axon, to have this sort of catalog of parts to go along with the exploded axon, and then just show the sort of parametric variability with the 3 by 3 sort of phylogram, right? This sort of idea of showing and altering the parameters and showing this sort of variability, right? That you can generate from the parametric model, right? Clear as mud? So that's the drawing part. The stuff I was showing with all of the measuring and the coloration, again, I apologize, we just don't have time for it this year. I don't know how we blew past, but I'm looking at the time and it's like we have 1 week left. You have to laser cut, assemble. Some of you may be already done with that, but you have to do these drawings. I think that's enough. I think that's plenty. All right. And so, yeah, this is it. So what I'll do is I'll post this example along with this demonstration video and the assignments for today on Canvas once class is over for you to reference. Wednesday will be our last meeting time, last formal meeting time between now and the deadline for project 2. So it'll just be all day, sorry, not all day, but all class time will just be troubleshooting, debugging, Q&A. You know, if you need help, come in, and if you don't need help, then, or if you're not here, I assume you don't need help and everything's all Jake. All right. Let me go ahead and stop sharing. Maybe I'll save this too, since I promised I would post this. There we are. Yeah. Okie dokie. Stop sharing, and I'm going to stop recording.